Hello, welcome back to our series on LangChain4j framework. Today in this tutorial, we are going to learn how we can connect our LangChain4j application with local LLMs that are running inside the LM Studio. LM Studio is basically a desktop application with the help of which we can download and run the open source models on our local computer. So this is the official website of LM Studio, which is lmstudio.ai. And if we have to download the setup for the same, we can simply click on the download button, and based on our operating system we can download the same. Once the LM Studio is downloaded and installed on our system, then we can search for the required model and download the same within the LM Studio itself. And once the model is downloaded, we can chat with the same, or if we have to integrate our LangChain4j application with these local models, in that case we will have to expose them over the REST APIs. For this, we have the functionality of local server available within the LM Studio. Once we activate the local server, post that our local models will be exposed over the REST APIs which our application can make use of. Now we are going to see all these steps one by one. This is the LM Studio application. Now if we have to download any model, we can go to the model search screen, and inside the search bar we can type the name of the model like Google Gamma. So here you will see many different options are available. In this tutorial, we are going to work with Google Gamma 3 1 billion parameter model, which is already downloaded on my system. But based on your requirement, you can search for any model, and if you have to download the same, you can click on the model name, and here you will see the download button, which will download the required model inside the LM Studio application. Now it might be possible that the particular model may have many different quantized version available, which you can see by clicking on this drop down button, and based on your requirement you can select and download the same. So in our case, Google Gamma 3 1 billion parameter is already downloaded on my system, because of which we are seeing the chat option here. So once the model is downloaded, you will see the downloaded models inside the My Model section. So in our case we only have one model, and if we have to chat with this model, we can go to the chat screen. First we will have to load the model, which will load the model inside the system memory. So in our case we will load the Google Gamma 3 1 billion parameter model. So once we click on it, it may take some time to load the model inside the memory, and once the model is loaded, we can simply chat with this model. So yeah, the model is loaded. We can ask any query like how are you, so it will simply respond. So yeah, you will see we have received the response from Google Gamma 3 model. And if we have to unload this model from the memory, we can simply click on this eject button. So the model is unloaded from the memory now. Now this is how we can interact with the model within the LM Studio. Now if we have to expose this model over the REST API, in that case we will have to activate the local server. For that we need to go to the developers option, and here you will see there is an option of local server. By default the status will be stopped, and if we have to expose our model over the REST API, we will have to activate this option. But before that, we will have to load our model inside the memory. So there is the load model button, and on clicking the same we can load the downloaded models. In our case we will load the Google Gamma 3 1 billion parameter model. So once the model is loaded, we can start the local server, and we can make use of the REST APIs to interact with these models. When it comes to the LM Studio, there are different type of REST endpoints that are exposed by the LM Studio. So there are three types mainly. First one is the official LM Studio set of APIs which we can make use of in order to interact with the models. Another one is the OpenAI compatible endpoints. In our tutorial we are going to make use of this. And then we also have the entropic compatible endpoints which we can make use of. So in our case we are going to work with the OpenAI compatible endpoints, and specifically we are going to make use of the V1 chat completion endpoint, which will generate the text based on the query which is submitted by the user. Now the model is loaded inside our memory. We can simply start the server. So here you will see the server is reachable over the localhost, and the port is 1234. And inside the developer logs, you will see the set of APIs that are exposed by our local server. Now our model is exposed over the REST API, and if we have to interact with it, we can simply send the post request to this particular endpoint, which is V1 chat completion endpoint, which is the OpenAI compatible endpoint, and the port number is 1234, which is the default port over which our models are available. And inside the request body, we need to specify the name of the model. and the messages that we want to send to the model. And here we have set the stream option as false. Now when we will send the request, our query will be processed by the Google Gamma 3 model, which is running inside the LM Studio, and we will receive the response. So here you will see we have received the response from the LLM. So now we covered the basics of LM Studio. Also we understood how we can expose these models over the REST API and how we can interact with the same. Now we will focus on creating our LangChain4j application, which will interact with the local LLMs that are running inside the LM Studio. Now we are going to develop a very simple chat-based application with the help of LangChain4j and Spring Boot. Inside this application, we are going to create a very simple REST endpoint that can be called by the end user, within which they can submit the query. This query will be processed by the local LLMs that are running inside the LM Studio. And once the query has been processed, we will send the response back to the user. So this is how our overall project structure will look like, wherein the name of our application is going to be the LangChain4j chat model LM Studio demo. Inside this application, at the very top, we will have the Spring Boot main class. Then inside the config package, we are going to have the application configuration. Inside this class, we are going to create our chat model programmatically. And then we have the controller, inside which we have one controller class named as chat controller. Inside this controller class, we are going to create a REST endpoint that can be called by the end user, with the help of which they can ask any query and receive the response. And then inside the resources folder, we have the application.yml containing very basic configuration. And finally, we have the pom.xml containing project related configuration. So now let's go through our application code base, starting with the pom.xml. At the very top, you will notice we are making use of Spring Boot version 3.5.11. When it comes to Java, we are making use of version 21. And for LangChain4j, we are making use of latest stable version, which is 1.11.0. Coming to the dependencies section, first we have added the Spring Boot starter web dependency, which will help us to create the REST APIs. Then we have added the LangChain4j OpenAI Spring Boot starter dependency. As I mentioned earlier, we are going to make use of the APIs that are compatible with the OpenAI standard. That is why we have added the OpenAI specific dependencies. Then we have added the LangChain4j HTTP client JDK dependency. Now there is a reason why we have added this dependency. When it comes to the LM Studio, it only supports the HTTP version 1.1, and by default, when we will send the request to the LM Studio via chat model, it will try to make use of HTTP version 2.0. Now with the help of this dependency, we will create our custom HTTP client, wherein we will enforce the HTTP version 1.1. Now coming to the dependencies management section, we have added the LangChain4j bomb dependency, which will be used for the version management. Now coming to the application YML, here we have only added the name of the application. Then we have the Spring Boot main class. This is the standard Spring Boot main class which will bootstrap our application. Now coming to the config package, we have this class named as application configuration. Inside this class, we are going to create a chat model programmatically. Until now, we used to configure the chat model inside the application.yml with the help of the properties that are offered by the LangChain4j. But in our case, we have to enforce the HTTP version 1.1, because of which we are creating our chat model programmatically. So for this, we have created one method named as chat model, and when we will expand that, here you will see we are creating the instance of OpenAI chat model using the builder pattern, within which we are specifying the similar configuration, like LangChain4j framework requires the API key to be specified. So here we have configured the same. Since we have not configured the authentication inside LM Studio, we can provide any dummy value here. And then we are specifying the model name. In our case, it is going to be Google Gamma 3 1 billion parameter. Then we have specified the base URL of LM Studio, which is running on localhost port 1234, and the base path is /v1. And for logging request and response, we are setting these two flags to true. Now we have to enforce the HTTP version 1.1, for which we will have to create our custom Java HTTP client. So with the help of builder, we are creating the same, within which we are specifying the HTTP version as 1.1. And once we have our custom Java HTTP client, we need to specify it inside the OpenAI chat model. For this, we have this option named as HTTP client builder, inside which we are specifying our JDK builder. And here you will see we have mentioned the JDK HTTP client builder. So this is the wrapper which is provided by the LangChain4j framework. Inside this wrapper, we are specifying our custom Java HTTP client. So in short, we are creating the OpenAI chat model, and also we are enforcing the HTTP version 1.1 with the help of custom HTTP Java client that we have created. Now coming to the controller package, we have the chat controller class. Inside this class, we are going to create a REST endpoint that can be called by the end user. So at the very top, we have specified the base path for our controller, which is /API/v1. Then we are going to create the post type of endpoint, for which we have this method named as simple chat. Here we have specified the post mapping, and the path suffix for our endpoint will be /chat. Now in order to receive the JSON request from the user, we have specified the request body with type as map of string of string. So in this case, the JSON request that will be sent by the user will be mapped here in the form of key value pair. Once the request has been processed, we will send the JSON response back to the user, for which we have specified the type as map of string of object. Now we will expand this method. So here first, from the request body, we are extracting the query which is sent by the user. Here we are assuming that the user query will be present inside the field named as message. Once the user query has been extracted, we need to send it to the LLM. For that, we have the chat model interface available. And if you remember, inside the application configuration, we have already created the bean of OpenAI chat model. Now we need to utilize the same. So first we will have to inject it inside the controller. So here you will see, with the help of constructor injection, we are injecting the chat model. So once we have the chat model available, we can simply call the chat method, inside which we will send the query which is asked by the user. Once the query has been processed, we will receive the response from the LLM in the form of string. So here we are storing the response. Once we have the response, we need to send the JSON response back to the user, for which we are creating the map of string of object. Then we will create the response field with the name AI response, and inside that we will send the response that we receive from the LLM. Once the map is ready, here we are simply returning it back to the user. So this is how we can create a very simple chat endpoint which will interact with the local LLMs that are running inside the LM Studio. Now our application is ready. We can test the same, but before that we need to load the model inside the LM Studio, and also we need to start our local server. So here you will see the local server is already started and the port is 1234, and the model that we have loaded is Google Gamma 3 1 billion parameter model. Now we will start our Spring Boot application and simply test our chat endpoint. Yeah, so our application is started. Now in order to test our endpoint, we need to send the post request to this particular endpoint, which is /API/v1/chat. Inside the request body, we need to specify the JSON payload. The name of the field should be message, inside which user can ask any query. So here we are asking the simple query like explain the difference between JDK and JRE. Now when we will send the request, behind the scenes the request will go to the Google Gamma 3 model which is running inside the LM Studio. It will process our request and we will receive the response. So yeah, we have received the response from the LLM. Yeah, now if we go to the application logs, here you will see the request and response logs are getting printed because of these two flags that we set to true inside the application configuration. So here you will see the request log is being printed, which is nothing but the request that was sent to the LLM. So here you will see the URL is localhost port 1234 and the endpoint is /v1/chat/completion, which is the OpenAI compatible endpoint. Here the model name is mentioned, which is Gamma 3 1 billion parameter model. Also the query which was asked by the user is mentioned here. And here you will see the response that we received from the LLM. And inside the content, this is the actual content or we can say the actual response that we receive from the LLM. Now I would like to showcase you one scenario wherein we have removed all the configuration related to the HTTP version 1.1. So here you will see we have commented out the code related to custom HTTP client. Here also we have removed that configuration, and if we go to the pom.xml, we have removed this particular dependency related to HTTP client JDK. So now behind the scenes, by default it will try to establish the connection using HTTP version 2.0, and in that case we will start receiving the errors. So I have already restarted our application, and now when we will send my request, here after waiting for 1 minute you will start noticing the IO error stating request cancelled. So basically it is unable to establish the connection with the LLM that is running inside the LM Studio. So yeah, here you will notice after waiting for 1 minute the request was failed, and here you will see we have received the IO error stating request cancelled, and it is trying to retry the same. So again the next request will fail. Basically it is unable to establish the connection because of the HTTP version 2.0. That is why enforcing the HTTP version 1.1 was important. Now I would like to showcase you two important settings in case of LM Studio. Let's say you want to configure the authentication for the local server. In that case you can go to the local server option, click on the server settings, and here you can enable the authentication toggle button. So once you enable it, then you can create the API keys with the help of manage tokens. So by default no API keys will be available. Here you can click on create new token, give some name, and once this has been done you will get the API key. So now while making the call to the LLMs over the REST API, you will have to specify the API key. Now another useful option is, let's say you have the multiple devices on your local network and they want to interact with the LLM that is running inside the LM Studio. This is how they can do. So inside the local server settings, you can enable this option which says serve on local network. What it will do, it will expose your model over your local IP address. So in this case, all the devices that are connected on the same local network or over the same Wi-Fi network, they can interact with these models with the help of local IP that is shown here. Yeah, so this is how we can integrate a LangChain4j application with the local LLMs that are running inside the LM Studio. For this, we have also written one detailed article which you can go through if you are interested. Also, the code base that we discussed in this tutorial is uploaded on GitHub. You can simply check out the code and try the same. Yeah, so that was all from my end. I hope you found it useful. Thank you.